Hello everyone, my name is Luke Hanks, and this is my Lab 2 video for Physics 2212. And so the purpose of this lab is basically just to reapproach what we did in Lab 1 with the charge tapes, and we're going to use a more accurate model this time. So instead of treating the tapes as point charges, we're going to treat them as line charges that have the charge evenly distributed along the length of the tape. And then we're going to replicate this model in GlowScript. So the results that I found I found the magnitude of the gravitational force and the electric force was equal to 2.403 times 10 to the negative 3 newtons, and then the charge on the tape is 2.797 times 10 to the negative 8 coulombs. And so the physics principles I used the Coulomb's law for the electric force, and then the electric field is equal to the integral of dE, where dE is the formula listed there, and dq is lambda dx, where lambda is just charge per unit length. And then, of course, we have the gravitational force is mass times the gravitational constant times j hat. So for my data, I just used the same data for Lab 1, but for one minor change, I re-estimated the charge to account for the more accurate model. And so here's my GlowScript model. I just made the assumptions I made here were that the tapes are line charges with even distribution of charge, and as you can see, my final charge that I found was 2.797 times 10 to the negative 8th coulombs. And this is a discrepancy between Lab 1 and Lab 2, where I found the charge was 1.245 times 10 to the negative 8th coulombs in Lab 1. And then any other discrepancies between the real world and my model just come from things like unaccounted forces and inaccuracies in measuring that I made. And then overall, my results showed the gravitational force and the electric force have equal magnitude of 2.403 times 10 to the negative 3rd newtons. So here's my first coding slide. So in the first part, I just inputted some constants such as the mass and the charge. And then in the second picture, I defined the function for the electric field, which is basically just Coulomb's law without one of the charges. And then for my second coding slide, I just adjusted the vector scales for the electric field and the electric force, and then of course the gravitational force. And then I adjusted the starting position for the vectors representing the top tape and the bottom tape. And then for my third coding slide, I just defined the electric force on the top tape, and the axes for both the electric and gravitational forces were inputted. So finally, the what if and why questions. So the what if question is basically asking what's the difference between Lab 1 and Lab 2, the results between the models. And so, as I already stated, in Lab 1 my charge was 1.245 times 10 to the negative 8th coulombs, and in Lab 2 my charge was 2.403 times 10 to the negative 3rd coulombs. So these estimates, they differ, and which value is more likely to be closer to the real value and why. So they differ because they're completely different models. So when you're treating the tape as a line charge, you have electric field coming from several different point charges along the tape, but in the point charge you just have one point charge. And the value that's going to be more accurate is one with the line charge, just because it's more close to how the real world works. In real life, the tape is not a point charge. And that's my lab. Thank you very much.